every time you cannot poke a patient with a pin, or you cannot give a sensory input regularly to know whether the reflex integrity is nice or not. So what you use to find out the spinal integrity in the clinical practice is your deep tendon reflex, that is called as the stretch reflex. So when I say stretch reflex, you should know something about a muscle spindle. So the muscle spindle is nothing but a small chocolate-like substance which is there in the muscle. When I say chocolate, because whenever I see a muscle spindle diagram, I always remember about a chocolate, a small candy wrapped up by paper. So this substance are connected parallelly to the extrafusal muscle fibers. What are extrafusal muscle fibers? They are nothing but the long muscle fibers which are running in a muscle, because you know that muscles are made up of a lot of muscle myofibrils, and myofibrils combine together to form the muscle fibers. You can see the actin myosins here in this muscle fibers. Here you can see the actin and myosin dark zones and the bright zones. So this is the extrafusal muscle fibers, and you can see that the muscle spindles are connected parallel to them. Okay, so what is the role of this muscle spindle? The muscle spindle has some sensory nerve fibers which are surrounding the there. Uh, this is called as nuclear bag fibers, and you have nuclear chain fibers. So there are nerve fibers which are surrounding these sensory receptors, and when the sensory receptors, which are very sensitive, get stimulated, this information passes on through this particular sensory nerve fibers. Again, this nerve fiber information goes to the posterior horn cells. Okay, so when they can be stimulated, the can be stimulated only when they are stretched. When I say they are stretched, when I say stretching, a mild stretch, even a mildest of the mild stretch, can stimulate the muscle spindle. So when when the muscle is contracting, these muscle spindles will not get stimulated. Can you see this? The firing rate of the muscle spindles when the muscle is contracting is less. This is the normal resting state. But when the muscle is getting stretched, then you can see that the muscle spindles are firing much faster than the others. So now, when I tap a knee hammer onto a patient, what happens? The muscle spindles first get stimulated because they are very sensitive. So they get stimulated because when I tap, there is a very mild stretch that is happening in the muscles, the tendon, and that is pronounced in the muscle spindle. So upper information, you see blue color line, which goes all the way up, and it goes posterior horn cells. From the posterior horn cells, two alpha motor neurons are stimulated. What are they? Alpha motor neuron for the agonist, alpha motor neuron for the antagonist. But how they are stimulated? One is excitatory, inhibitory. The one on the red is excitatory. Okay, and another one on the lavender color is the inhibitory. The alpha motor neurons of the agonist are going to be facilitated, and the alpha motor neuron of the antagonist is going to be inhibited. This is called as reciprocal inhibition. When only this muscle, hamstring, is relaxing, the quadriceps can contract and produce a small oscillation of the feet. If you imagine, if the antagonist is not being suppressed or antagonist is not being inhibited, both these muscles will contract and there won't be any activity. So this is called as the reciprocal inhibition. So this is nothing but stretch reflex. When you tap your knee hammer on the tendon of the muscle, you get a small oscillatory response in the leg, or you can see a palpable or visible contraction of the quadriceps muscle. This is called as the stretch reflex. Am I right? So this mechanism is also influenced by some central nervous system, the influenced by the brain, basal ganglia, and the reticular activating system, which we will see later. When I'm telling you about this spasticity, we'll know about this. So now As of you just remember whatever I have taught you, that the stretch details. Now there is one more anatomical structure called as the Golgi tendon organ. What is a Golgi tendon organ? There is a difference between the muscle spindle and the Golgi tendon organ. Where I said that the muscle spindles are connected parallel to the muscle fibers. The Golgi tendon organs are connected in series with the muscle fibers. So in electronics also, you know the difference between coils connected in parallel and coil connected in series. Which conducts very fast? Coils conducted in parallel conducts faster than the coils which are conducted in series, because they undergo a lot of resistance. Likewise, any sensory input from the muscle can influence the muscle spindle more compared to the Golgi tendon organ, because you can see that the Golgi tendon organs are not attached parallel to the muscle fibers, but they are attached series. When I say parallel, these are the extrafusal muscle fibers and this is the Golgi tendon organ here. So they are connected parallel. So when I say series, this is the extrafusal muscle fiber and the Golgi tendon organ is connected here. So that is meant by series. So tell me, when there is a small muscle stretch, which can get stimulated first, this muscle spindle or the Golgi tendon organ? It is the muscle spindle, because it can experience it much earlier than the Golgi tendon organ, which is connected in series. So what is the role of the Golgi tendon organ? When the Golgi tendon organ is stimulated, the muscle goes for a relaxation. Whereas we saw that the muscle spindle, when it gets stimulated, it goes for a contraction of the muscle, extrafusal muscle fibers.